My background is in engineering and specifically in military space operations. So when it comes to the creation issue, there's many different aspects of it we can talk about, of course. I happen to like astronomy because that's my background. So given the theme of the conference here today and tomorrow, we talk about a universe that is cursed as a result of man's sin. Despite the fall of man and that curse, though, is there still aspects of creation, aspects of design that are visible within the universe that we live in? And the answer is yes. Despite the curse, there is still much beauty and much evidence of design in the cosmos that we live in. So that's going to be the theme of my talk here this afternoon. And I'm going to argue that many aspects of the universe are Goldilocks values. They're not too much and they're not too little, they're just right. And in many cases, the range of acceptable parameters for life to be possible is very narrow. We'll see that as we go. There's a lot of evidence of design in that many parameters, if you will, of the universe are finely tuned, apparently, to support us. So there's many different ways we can approach this. I like to approach it from the near to the far. So we'll start with the Earth, and we'll work our way outwards to bigger and bigger scales and see what we can observe as we go. So, of course, we live on the Earth, which is within a solar system, which is within the Milky Way galaxy. And the galaxy, of course, is one galaxy within 100 billion or so of the universe itself. And as we look at aspects of this at various scales, we'll ask the question, does this look random, just the result of natural processes operating all by themselves over billions of years? Or do these objects and systems look designed? Now, the Bible tells us that we should be able to expect these things to have evidence of creation within them. As Genesis 1 says, in the beginning, God created the heavens and the earth. However, this is not an acceptable explanation, of course, within the broader scientific community today because this is a supernatural explanation. And we are told that supernatural explanations are not allowed within science. So what does the word supernatural even mean? Well, the prefix super means above or beyond. So that which is supernatural is that which is above or beyond the natural world that we can observe. And we are told instead that naturalism is the only acceptable worldview when looking at science. The idea that natural processes alone are allowable to invoke when trying to understand the world and the universe around us. The Bible also talks about the universe being designed for many purposes, to provide signs and seasons for mankind, to sustain life here on earth, and above all, to declare his glory. It says that explicitly. Now, again, I'm going to argue that there's much evidence of this within the universe that we see. Interestingly enough, even some non-creationary scientists acknowledge some aspects of this. The book on the left here specifically was written by two secular authors talking about how rare the Earth is within the universe and how unlikely its combination of characteristics is. The book on the right was written by someone who does acknowledge design, although not from a creation perspective necessarily. But despite even this acknowledgement, these scientists aren't really going far enough. When you really take this viewpoint to its logical conclusion, you see some interesting things emerge. And so that's what I'll be doing in this presentation. So what does the secular view represent? The non-creationary approach to understanding the universe says that in the beginning, there was a quantum fluctuation of the vacuum which produced the universe. So what exactly is this referring to? Well, supposedly there was nothing, and then there was a fluctuation of the nothing, and then something appeared and became everything. So nothing fluctuated and made everything. Is nothing something that can fluctuate? Well, no. We'll actually talk more about this in my presentation tomorrow. For now, we'll set this part of it aside and say, well, if this actually is the explanation for the universe, and if the Big Bang model specifically is the correct history of how this all developed afterwards, would we get the universe that we see if this were true history? So let's start our examination with the Earth. Now, the Earth supposedly formed with the rest of the solar system out of a solar nebula, a large cloud of gas and dust, roughly 4.5 billion years ago. And the Earth, it turns out, is within a narrow distance from the sun within the solar system, known as the habitable zone. If your planet is too close to the sun, then it is very hot there, of course, as we see in Mercury and Venus. And too hot means liquid water can't be possible. Conversely, if you're too far away from the sun, then water will be frozen, and of course liquid water won't be possible there either, and so this would make life very difficult, as you can imagine. But the Earth is in that narrow Goldilocks zone where it's just right in terms of its distance from the sun and the temperatures that we have here, which is why we have liquid water. And you'll often hear this phrase, habitable zone, when they're talking about planets being discovered around other stars, and they'll say, well, look, this planet is within that star's habitable zone, so maybe there's life there. Thus implying that being within this particular range of distances is sufficient to support life, which is really silly. I mean, even here in our own solar system, we see something else that's within the habitable zone that is certainly not conducive to life. I mean, our moon is within the habitable zone. Is it a pleasant place? Can it support life? Well, of course not. There's also a problem with this too, by the way. Just because the Earth is in the habitable zone today where liquid water is possible, if you actually study the model of how this all supposedly came to be, the Earth actually couldn't have liquid water on it today because water could not have formed at this distance from the sun within that particular cloud of gas. But moving on from that, I'm going to argue now that the Earth is more than just within a particular distance, a habitable zone. It's actually uniquely designed for life and to support life. For example, we have a protective magnetosphere, a magnetic field surrounding the Earth that deflects solar radiation and helps us to retain our atmosphere. Without the magnetic field, solar radiation and cosmic radiation would eventually strip away the atmosphere, and of course that would be very bad for us. The rotation period of the Earth is 24 hours. Now, that's where we get the length of our day, of course. We go all the way around once, 24 hours, and we tend to take that for granted. I mean, how many people woke up this morning and thanked the Lord that the day is 24 hours long? Not something we think about, right? But it turns out that 24 hours is just right to have life here. If the Earth rotated more quickly, we would have more violent winds and storm systems on the surface, which would not be good for us. If it rotated more slowly than it does, then any given point on the Earth's surface would be exposed to sunlight for longer and thus get hotter, and then be on the night side of the Earth for longer and thus get colder. So we would see much wilder temperature swings. But no, 24 hours is just right. And furthermore, 24 hours is not some default number. If a planet could form out of substances from natural processes, you don't automatically get this nice 24-hour period. We see this even within our own solar system. Jupiter, for example, has a day of 10 hours long. It rotates all the way around in just 10 hours. At the opposite extreme is Venus, which takes 243 Earth days to rotate on its axis once. It also rotates backwards, by the way, but that's a different story. So 10 hours to 243 days is a pretty broad range for the length of a day, right? But we just happen to have that 24-hour period that's just right to give us a moderate climate here. The same is true for our axial tilt. The Earth is tilted about 23.5 degrees relative to the plane of the ecliptic. That gives us moderate seasons. Now again, we tend to not think about this, but this isn't some natural number for an axial tilt to be either. For example, Mercury has basically no axial tilt at just 0.01 degrees. So it doesn't have the seasons that we do. The opposite extreme is Uranus, which is actually tilted all the way over, almost 98 degrees. It actually rolls along sideways through space like a ball rather than spinning like a top. So imagine a season on Uranus would last for years because you have a pole pointed at the sun for a long period of time, years and years, until it gets on the other side of the sun where the opposite pole is. But the Earth doesn't have either of those kind of extremes. We have 23.5, which is just right. The Earth's orbit is also nice and circular. Not perfectly circular, but it's pretty close. We tend to take this for granted, but that's not a natural number either. For example, Mercury's orbit is much more eccentric, much more elliptical than the Earth's is, and it actually receives twice as much energy from the sun at its closest point compared to its farthest point. So imagine how much climate change there would be here on Earth over the course of each year if we had an orbit like this. But that's not what we have. Ours is nice and circular, which is just right. The Earth's atmosphere, were it too thick, we would have a massive greenhouse effect like we see on Venus. Venus is sometimes called Earth's sister planet because it's about the same size and mass as the Earth and as our next door neighbor in space. But it has a very different, very drastically different climate than we have. The atmospheric pressure on Venus is 92 times that of Earth's. So just standing on the surface, you're subject to the same pressure as if you were 3,000 feet deep under the ocean on Earth. You can imagine what that would be like. Not that you could survive there anyway, because the temperature is almost 900 degrees Fahrenheit. And that's all because Venus has a different composition of its atmosphere and a bit thicker than the Earth's is. So we don't have a greenhouse effect on the one hand because our atmosphere isn't too thick and it's composed of the right gases, nor is it too thin, which we see is going on with Mars. Mars's atmosphere is so thin that it can't retain liquid water there, which is why it's a desert planet today. But the Earth's atmosphere is not too thin and not too thick, it's just right. There's other characteristics we could look at with the Earth, but we get the same answer each time. Do these characteristics look random, the outcome of natural processes, or does the Earth look designed instead? I'm arguing, obviously, that the Earth was designed for life, and nor should we be surprised by this anyway, because the Bible says so. For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it and created it not in vain. He formed it to be, what? Inhabited. So if an omniscient, omnipotent, benevolent creator made the earth for us to live here, then we shouldn't be surprised that it's very well designed to do that. Moving on from the Earth, we see the moon. Now, some of us tend to take the moon for granted. I mean, you see it in the sky frequently, and you don't think about it very much, right? You can also make arguments that the moon is designed for life as well. For example, the moon and the sun together raise tides in the Earth's oceans. And it turns out their combination of mass and distance is just right to raise beneficial tides. Were the moon smaller or farther away, the tides would be lower, and now you run the risk of the oceans becoming stagnant, which means things would die, and that would affect the whole food chain. Very bad for life on Earth. On the other hand, were the moon larger or closer, we would have much higher tides, which would be destructive to the continental coastlines. But its position and mass is just right for beneficial tides. It's also uniquely positioned. The moon's about 400 times smaller than the sun, but it's about 400 times closer than the sun. So therefore, its apparent size in the sky, when we look at it, is the same as the sun. And it's in an orbit, which is also unusual, so that at certain times and from certain locations, the disk of the moon will move in front of the sun and produce a total solar eclipse. Now, there's over 200 moons in the solar system that we know of so far. Out of all of them, over 200, the moon is the only one that has the correct combination of apparent size, distance, and orbit to produce perfect solar eclipses like this for observers on the planet that the moon orbits. And it's interesting, is it just a coincidence that the only place where these events are observable is also the only place where there are observers who can see them? I don't think so. I don't believe in coincidences. The moon is also uniquely stabilizing. It turns out that over long periods of time, were the moon not in the orbit that it is, the Earth's rotation around its axis would become chaotic, and the Earth's axial tilt would begin to vary, which would have catastrophic effects on our climate. As this author notes, Earth's obliquity would vary chaotically from 0 degrees to 85 degrees on a time scale of tens of millions of years, were it not for the presence of the moon. Earth's climatic stability is dependent to a large extent on the existence of the moon. Now, of course, this is an argument based on millions of years, which I don't believe in. However, I think it's interesting. Many of the arguments that we'll see here this afternoon, by the way, even if you do believe in the millions of years, or in some cases the billions of years, you still are forced to acknowledge that these characteristics look finely tuned. Because indeed the moon is finely tuned in many aspects. It doesn't look random, it looks designed. It fulfills very well its stated purpose of being the lesser light to rule the night. And of course that phrase, if you're familiar with Genesis, also might remind you of the greater light that is meant to rule the day, which is the sun. Is there evidence for design in the sun? Well, yes, there is, turns out. First of all, the sun is a very important object to us. Of course, it's really responsible for supporting life here on Earth. Without the sun, we would not have the warmth that it provides. We would not have the food that it provides through growth of plants and so on. And of course, those plants, also through reception of sunlight, produce oxygen. So the sun is indirectly responsible for a lot of important things to sustain life here, right? I mean, food, warmth, oxygen, that's a pretty significant list. Nevertheless, atheists will tell us that the sun isn't really that big of a deal. If you do some reading in this, you'll see frequent quotes like this one from Carl Sagan, where he said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of the universe, in which there are far more galaxies than people. So our star is humdrum, he says, and our planet is insignificant, revolving around it. This author said, our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity. This author said, our sun, so important to us, is merely an ordinary garden-variety star. There's more quotes like this I could provide here. The point is, you frequently hear that the sun is just average, nothing special, it's mediocre, which is not true at all when you actually study stars. First of all, our sun is brighter than 90% of all stars in the Milky Way galaxy. That doesn't sound like mediocre to me. It has more mass than 92%. In fact, about 3/4 of all stars are red dwarfs, which, as you can gather by the name, are red and small. A red dwarf produces much less energy compared to our sun. But as I said, about 3/4 of all stars are red dwarfs. So if we orbited a typical star, it would be one of these. But we should be very thankful that we don't orbit one of these, because a star this small, to receive enough warmth from it, the Earth would need to be very close to it. So close, in fact, that we would be tidally locked to our star. A tidal lock means there's distortion of the object that's orbiting that prevents it from rotating, so that the same side always faces the object it's orbiting through the course of an orbit. We see this with the Earth and the Moon. The Moon is tidally locked to the Earth. That's why we always see the same side of the Moon, regardless of what time during its orbit we look at it. Well, if the Earth were orbiting a red dwarf star, we would be tidally locked to it. So one side of our planet would be permanently bathed in solar radiation, while the opposite side would be permanently on the night side. So you'd have extremes of hot and cold, roasting on one side and freezing on the other, not conducive to life. Not that we would last very long there anyway, because it turns out red dwarf stars are also very unstable. They're sometimes called flare stars. They frequently erupt in large blasts of solar material going out into space. We're a planet in the path of one of these flares. That, of course, would not be conducive to life either. But even looking beyond dwarf stars, looking at high mass stars, so now we're down to 1/4 of all the stars that we know of. 80% of those are in binary or multiple systems. In fact, more than half of sun-like stars are in multiple star systems. And these would make life very challenging as well, because any planet orbiting it is sometimes receiving radiation from 2 stars, at other times it's only receiving from 1, as the other is behind it from its point of view. So you can imagine how violent the climate changes, swings would be there in that situation too. But that's not what we have. We have a single star system. The sun, furthermore, is a Class G star, of which only 7.5% of all stars are. And even among Class G stars, our sun is unique. It is unusually quiet. What do I mean by that? Well, a while back, they concluded a 30-year study of the sun's photosphere, and they found that its energy output varied by less than 1/10 of 1%. So essentially constant. Now, again, we take this for granted. I mean, the sun comes up in the morning, we go about our business. We don't think about how amazing it is that we have a stable sun. But we should be amazed, because stars don't work this way. Even solar-type stars, turns out, are much more violent on a much more frequent basis. This particular study talked about superflares being found on ordinary solar-type stars. So what's a superflare? Well, you're probably familiar that the surface of the sun is an active place with lots of stuff going on. Once in a while, you see a flare. There's an eruption of material here, and then a flare occurring with it. And these can get pretty impressive on our sun. Here's the sun here. My pointer doesn't work on the screen, so I'm going to use this one. So here's the surface of the sun. Here you see this eruption here, this prominence, compared to the size of the Earth. Now, this, of course, happens once in a while. Doesn't generally affect us that badly on Earth. Once in a while, we'll have a communications network problem or something, but that's a result of technology, not something that's going to directly impact life. So even as impressive as our sun's surface looks sometimes, it doesn't tend to directly affect us that much. But multiply a typical solar flare on the sun by 10 million times, that's a super flare, which is what sun-like stars all of them except our sun, normally produce, and they produce them fairly often, once a century or so. Once every 100 years is scarily frequent when you're talking about something that can sterilize an entire planet, right? But this author goes on, but a superflare hasn't occurred on the sun in recorded history. And why that is unclear. Well, it's not unclear. It's because the Lord created the sun-earth system as a place for us to live, which is why the sun, despite being a sun-like star, doesn't operate like a typical sun-like star does. And just for perspective, I mean, we tend to see stars in the sky and they're little twinkly lights and we don't think about them that much. Stars can be very violent things. This one is in the process of exploding. That thing in the middle is the star, and then you can see all this gas and other material blasting out of it. This one is exploding in two different directions at once. There's a star in the middle of that blowing out this way and that way simultaneously, a dual-lobed explosion. Now, these are admittedly extreme examples, but the point is stars are not quiet, stable things, but our sun is, which means it's not mediocre, right? As this author admits, some of the popular perception of the sun is downright wrong. Writers sometimes tell us it's just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. This author says, people say the sun is a typical star. That's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden places like Earth where it can exist. And I thought it was interesting, the Garden of Eden reference, this quote's from the New York Times. Not typically a publication that'll be quoting the Bible. So does the sun look random, the result of natural processes operating just according to laws of physics over billions of years? No, it looks designed. And that's because it is unique. Looking out on a larger scale, what can we glean from this? Well, surrounding our galaxy are clusters of stars called globular clusters. Turns out that you don't want to have your planet inside one of these. They're called dead zones because they would be very hostile to life. Now again, this is from a long-age sort of perspective, but even coming from their perspective, they have to acknowledge that were a planet to develop here, well, these stars are metal poor, which means the planets around them will not have the right composition to support life. Moreover, any planet in the midst of this would have multiple stars very close to it, so its orbit around its star would be very unstable. Again, you'd receive much more strong variation in the amount of radiation being received. What about elliptical galaxies? Well, those are dead zones too for similar reasons. If you want to have a place where it's possible to have life, you want your planet to be in a spiral galaxy. And indeed, the Milky Way is a spiral galaxy. But being a spiral galaxy isn't enough because you have to be in a certain place within it. You don't want to be at the center of a spiral galaxy because that too is a dead zone. You have supernova explosions, you have gamma ray bursts, harsh radiation, bad things happen in the center of galaxies. But you don't want to be out on the edge either because there's bad stuff going on there too. Among other things, the stars are not the proper composition to have conducive environments for life. No, you want to be in a spiral galaxy and you want to be right about here. And guess where the Earth is? Right about here. Moreover, people have pointed out, not only is the Earth, or the sun, and of course we orbit around the sun, not only is the Earth in a perfect place in terms of distance from the center and the edge, it's also between two spiral arms, which means we receive a lot less radiation than the otherwise would. Furthermore, we're in a perfect position to be able to observe the rest of the cosmos. If we were in the middle of a spiral arm, or certainly closer into the center, our nighttime sky would be full of stuff. You wouldn't be able to see out beyond it because your view is very cluttered. But we're in the perfect position not only to survive, but also to perceive God's glory from here. So our Earth-Sun system is designed for life, and as I just mentioned, also good for observation in its position and other factors. Now, there's many more items that we could talk about just talking about the Earth and Sun and our solar system alone. If you take the secular view to its logical conclusion, you come up with a long list of things that are very unusual about the Earth. Now, I don't have time to talk about all these. I've covered a few of them already, but just to show you the number of parameters that we're talking about here that secular authors have acknowledged. Within the solar system, you have to have roughly the same type of planets that we have today, and they have to be roughly the same kind of, the same locations that we have today. Jupiter has to have certain characteristics. Looking at the Earth itself, there's a long list of parameters that have to be all just right in order for life to be possible here. And as I said, I don't have time to discuss each of these. We could have a whole session just on these. But it fascinates me, even though many of these, again, are coming from a long-age perspective, it fascinates me that the Lord has created things in such a way that even people who try to construct models that deny his creative handiwork still have to acknowledge how unusual and how finely tuned, and thus implication of design, that we see in the system that we live in. So, I hope you don't mind me skipping through all that, but as you can see, there's a lot there we could talk about, and there's other things that we want to move on for. Because it's not just the Earth where we can perceive this sort of design. The cosmos itself is finely tuned. What do I mean by that? Well, let's set aside the large scale for a moment and talk about the smallest scale, the laws of physics that the cosmos operates according to. Sir Fred Hoyle, who passed away a while back, and was certainly no friend to creationists, by the way, was studying the carbon atom, and he concluded that it could not be the result of natural processes. He said some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that his super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. That's from studying one atom, one type of atom, alone. This author took a different approach and looked at the forces that operate within atoms. Here's what he said. A change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different, and in many cases unsuitable for the development of life. For example, if protons were 0.2% heavier, not very much, right? They would decay into neutrons, which would destabilize atoms, which would be a very bad thing for those of us who are made of atoms, right? Our universe and its laws appear to have a design that is both tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained. It raises the natural question of why it is that way. Who said this? Stephen Hawking, famous atheist, if you didn't know that about him. Very much anti-God. So the laws of physics themselves and the constants that we see in our equations in physics appear to be finely tuned. In fact, the entire universe appears to have extreme fine-tuning, even if you come at it from a Big Bang perspective. For example, a number of years ago, some authors were calculating the margin of error within the Big Bang model for the balance between matter and energy. So early in the Big Bang universe, had the Big Bang happened early in its history, you would have this tension between the amount of stuff being produced and the amount of gravity that results from that. So the Big Bang is supposedly this expansion where everything is exploding outwards, not technically an explosion, but whatever, that analogy works well enough, while at the same time gravity is resisting that expansion and trying to pull everything together. And it turns out there's a real tightrope that the model has to walk between too much on this way and too much on the other way. And these authors calculated that the difference, the margin of error, is 1 out of 10 to the 60th power. Had there been a little bit extra stuff in the universe, then gravity would have taken over, matter would have collapsed into black holes, we wouldn't be here today because there'd be no stars and no planets. Conversely, had there been a little bit less stuff created by the alleged Big Bang, then expansion would have taken over because there wouldn't have been enough gravity to hold it all together. everything would have flown apart too quickly, galaxies wouldn't have formed, stars wouldn't have formed, planets wouldn't have formed, we wouldn't be here to talk about them. So if you accept the Big Bang model, it turns out there's an extreme amount of fine-tuning necessary, this fine balance between expansion and gravitational attraction. And your margin of error is 1 out of 10 to the 60th power. That's how big the margin of error is. Now that's 1 out of a number that's 1 with 60 zeros after it. What does that mean? That's just a big number. Well, if you think about this, there's about 1 to the 80th, or 10 to the 80th power atoms in the universe. And if your model says that this amount of stuff was produced by an event that was finely tuned out of 10 to the 60th power, then you divide the two out, and your precision is 10 to the 20th atoms. That's about the same amount of stuff as a single grain of sand. In other words, I probably lost some people there, that's fine. In other words, had the Big Bang, alleged Big Bang, happened and produced 1 extra grain of sand compared to what's in the entire universe, gravitational collapse would have predominated, everything would have become black holes, we wouldn't be here to talk about it. On the other hand, had it created 1 grain of sand less anywhere in the cosmos, expansion would have taken over, galaxies, stars, planets couldn't have formed, we wouldn't be here. So imagine how big the universe is, and this random event had to produce the amount of stuff we see with a precision of a single grain of sand. Does that sound like a random event to you? Then the problem got worse. Subsequent research shows that the Big Bang model actually has to be finely tuned to 10 out of the 123rd power. That's 1 out of this number. This author said, our universe appears surprisingly finely tuned for life, in the sense that if you tweaked any of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. So back to our analogy, there's 10 to the 80th power atoms in the universe. If this event that supposedly produced this was finally tuned to 10 out of the 123rd power, now we're less than a single grain of sand. We're less than a single atom within a grain of sand. We're 10 to the minus 43rd of the mass energy of a single atom. That's this fraction of the mass energy of a single atom compared to everything in the cosmos was necessary for this random event that didn't have a creator involved. As this very non-creationary physicist said, this discovery was a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe had to somehow form so that man could live here. And you can tell what he thinks of that idea by the adjectives he uses. And why doesn't he like this idea? Because it sounds like design, right? And if there's design, there has to be a designer, and he doesn't want that. So how do you explain a universe that's so amazingly finely tuned, from the smallest scale, the constants of physics and the laws of physics, all the way out to the amount of stuff produced by the alleged Big Bang itself? Well, there's 3 possible explanations. Number 1, the universe looks designed because it was designed by a designer. Of course, the secular folks don't like that. Some of them try to invoke survivor bias. They say, well, if the universe weren't so finely tuned to support life, then life wouldn't be possible, and so we couldn't be here to look at it. That doesn't explain anything, right? It doesn't explain how a random event could produce this amount of fine-tuning. So the increasingly popular explanation is called the multiverse. And indeed, this is now the most preferred solution among secular thinkers. What is the multiverse? Well, multiverse means multiple universes. So their explanation now is, yes, our universe looks amazingly finely tuned, but that's not really surprising because our universe is only one out of an infinite number of universes that exists. With an infinite number of universes, every possible combination of characteristics will be out there an infinite number of times. We just happen to be in one that happens to look so finely tuned. Now, you might be wondering, first of all, how can there be more than one universe? Because universe means everything. Well, they've redefined the word. Universe now means everything that we can possibly observe, even with the best possible telescopes and so on. Everything outside of our ability to observe, according to this new definition, is a different universe. And with an infinite number of these, again, every possible combination of characteristics will be out there an infinite number of times. And indeed, the Big Bang model now includes an infinite number of bubble universes always being produced. These universes have been produced eternally, long by this point. It's been going on forever and will continue to do so forever, which raises its own set of problems with physics, but we'll skip that for now. Let's look at the implications of this, though. If there are infinite universes out there, and every possible combination of characteristics is out there somewhere an infinite number of times, that means there's an infinite number of universes where we're having this same conference, sitting in this same room. In fact, there's an infinite number where the conference happened last week, because they're a week ahead of us in time, and there's an infinite number where it hasn't happened yet. There's an infinite number where you're sitting in your same seat, listening to the same talk, but you had something different for breakfast this morning. There's an infinite number of any possible variation that you can think of. As this article says, is there another copy of you, reading this article, a person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities, in a solar system much like our own? The life of this person has been identical to yours in every respect. If there's an infinite number of you out there, how valuable do you become? Are you a unique person created in God's image anymore? No. You probably find this idea strange and implausible, yet it looks like we'll just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a faraway galaxy. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. Remember this phrase, this is important. We'll come back to this. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many with people with the same appearance, name, and memories as you. They are you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history has played out. So there's an infinite number of universes out there where the South won the Civil War. There's an infinite number where there never was a Civil War because the 13 colonies lost the revolution against King George III. Right? Every variation you can think of is out there an infinite number of times, according to this idea. Because even the most unlikely events must take place somewhere. Now, you might think that I've gone off the rails by this point, that I'm making all this stuff up, but no, this is a mainstream idea in cosmology today. There are some very prominent scientists pushing this idea and saying that it's true. As this author said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like can you supersize or not, he says. Our cosmological history says it's there, and we need to deal with it. So regardless of how implausible or even ridiculous you might think this idea is, you just need to deal with it, because this is science. But is it really? What's the one thing that we know about all these other alleged universes? By definition, they are unobservable, right? So they are outside of our ability to observe. They're outside the natural world that we can see. What word did we use to describe that which is outside the natural world? Supernatural. Anyone see some hypocrisy here? We are not allowed to invoke supernatural explanations involving an intelligent designer and a creator, but they are allowed to invoke an infinite number of unseen and unseeable universes, which is equally supernatural. And even some secular thinkers acknowledge this and are unhappy about it. This author says that these theories don't deserve to be called scientific. This author complains about multiverse pseudoscience and says if a wrong idea is promoted for enough years, it gets into the textbooks. We don't know, we haven't seen that happen before, right? And becomes part of the conventional wisdom about how the world works. The issue, though, that I'm going to press going forward is not merely that this idea is untestable and unobservable, and not even that it's only wrong, it's actually absurd. Because push it to its logical conclusion and you'll see some interesting consequences. For example, Richard Dawkins has written there almost certainly is no God. And if you ever talk to a Dawkins fan, you can have a little conversation based on what we've just said. You said, okay, so a moment ago we were talking about the multiverse and how Most secular scientists believe this nowadays. Do you believe that too, Mr. Atheist? And they'll say yes. Well, Professor Dawkins has said there almost certainly is no God. Do you agree with that? Well, yes, I believe that too. So let me rephrase Professor Dawkins' statement, Mr. Atheist, and see if you agree with it. Would you agree that it's most unlikely that the God of the Bible exists? And he'll say yes. So, well, that's very interesting, because if it's most unlikely that the God of the Bible exists, but we live in a multiverse where even the most unlikely events must take place somewhere, therefore there is a God, right? Now, of course, the atheist will not agree with you, but the point is you can take their quote-unquote logic to an absurd conclusion where it contradicts itself. Because indeed, the multiverse does predict that even the most unlikely events must take place somewhere. And now let's apply a biblical principle to this proposal. The Bible said that ye shall know them by their fruits. So if the Big Bang Theory, which now includes a multiverse, were a good idea, it would produce good scientific fruit. Testable models consistent with the universe we see. Conversely, if it's not a good scientific model, it'll produce bad fruit, either predictions that are incorrect or just absurdity. So let's look at the logical implications of the multiverse theory and ask, is this a scientific theory, or is it actually just science fiction? Well, as this author said, in the multiverse, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. That means, among many other things, Captain Kirk and Mr. Spock are real people out there in actual universes doing everything you saw in the Star Trek series, even the episodes that were painfully cheesy to watch. This is history now, not science fiction. That's what the multiverse predicts, right? Because even the most unlikely events must take place somewhere. Now, some people would say, wait a minute, no, because science fiction and fantasy like Harry Potter, for example, that's real now too. Some people say, no, that's magic. I mean, that's not real. But wait a minute, the multiverse theory says different constants of physics can be produced in different universes, perhaps even different laws of physics. So Harry Potter's on the table now too, and the Lord of the Rings and every other story you can think of. It's all out there an infinite number of times. It's all real, according to this theory. Another author had a different take on this. He wasn't writing about the multiverse specifically, but the logic still holds. He talked about discovering life on other planets and how on our planet dinosaurs evolved but then got wiped out by a freak asteroid collision. But if we explore other planets, we might run into dinosaurs that didn't have that happen to them. He said such life forms that we encounter could well be advanced versions of dinosaurs, because they didn't die, they continued to evolve and get better and better, right? If mammals didn't have the good fortune to have the dinosaurs wiped out by an asteroid collision, we would be better off not meeting them. Well, yeah, because there's nothing worse than running into a dinosaur that has better weapons than you do, right? If the multiverse is real, right? So this author, unwittingly, basically admitted that even the little videos like this one, they're not science fiction anymore. This is a documentary of what's going on elsewhere. So who is responsible ultimately for all this fine-tuning that we see? Well, we of course would say it's the God of the Bible. Those who are unwilling to accept that, though, are applying the multiverse logic to solve this problem, or so they think. This author said, it is proposed that our universe was created by life of superior intelligence existing in another physical universe. With an infinite number of universes that have been out there in an infinite amount of time, surely there has been enough time and enough places for this to happen where aliens have evolved with good enough technology to design and build universes. So that's how our universe got here. This explains why the constants of physics have their observed finely tuned values and might even help us to understand why our universe is comprehensible to the human mind. So that's why the universe looks designed, not because God did it, but because aliens did it. But is this science, or is it just science fiction? Other authors have taken a little bit different slant on this. This author said it's a perfectly acceptable supposition that the world as we know it is a vast computer program run on machines built by an intelligence we know nothing about in a universe that could be like any of the ones we speculate about, or one that's totally strange and alien. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes, there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of a universe. And that's why it looks so finely tuned and designed. What does he mean by chances are? Well, that's what the math says once you accept the multiverse. Since we've had computers in our civilization, how many computer simulations have we run? I mean, some very large number, right? Who even knows what that number is? Well, if alien civilizations develop out there, and they develop the ability eventually to simulate entire universes, they will eventually simulate a countless number of actual universes. So one physical alien civilization produced, let's say, 1 billion simulated universes. Therefore, when you look at the 1,000,000,001 universes as a whole, the chances of any one of them being a real universe is 1 out of 1 billion. 1 out of 1,000,000,001. See how that works? So once you accept the multiverse idea and start speculating about aliens, the math actually says that any given universe is probably not real. It's actually just a simulation. So we don't live actually in a universe, according to the multiverse idea, on a planet surrounding a real sun and a real galaxy, etc. We're just living inside of a video game being played by some alien somewhere. Now, you might think this is silly, but there are scientists actually studying to try to figure out if this is true. And they're spending our tax dollars to do it, by the way. Doesn't that give you a warm and fuzzy? But wait a minute. If aliens can evolve to the point where they can simulate entire universes, which include us, they can also evolve to be able to simulate entire universes that contain aliens that are simulating universes, right? So there could even be multiple levels of simulation, as this author points out. The computer our universe runs on could be itself a simulation on a different computer. He's serious about this, by the way. This is not tongue-in-cheek. So it's not only that we're living in a video game being played by some alien somewhere, those aliens themselves are living in a video game being played by other aliens. But why stop there? Maybe those aliens are themselves part of a video game being played by aliens which are themselves part of a video game which are themselves, and you get the idea by now, right? Is this science? No. This is even beyond science fiction. This is just absurdity. But it's the logical implication of multiverse, right? It follows straightforwardly from that foundation. So why are intelligent scientists, intelligent men and women, endorsing the multiverse idea, even though it leads ultimately to this absurdity? Here's why. If there's only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse. Is that a scientific statement? Are these people being driven by scientific considerations? Now, maybe they think they are, but if they think that, they're deceiving themselves. Ultimately, this is driven by a rejection of God. So, by starting with the wrong foundation, a rejection of a creator, they wind up in a place that is absurd. The Bible says that the fool has said in his heart, there is no God. And again, don't get me wrong, I'm not calling these people stupid. They're very intelligent men and women. However, they're violating this psalm here, which says the fear of the Lord is the beginning of wisdom. When you reject the Bible, which represents wisdom, whatever it is you wind up believing is going to be foolishness. When you reject the truth, whatever it is that you wind up believing is going to be a lie. And that's where secular cosmology is today. It's not that science disproves the Bible, which is why scientists reject the Lord. It's that scientists are rejecting God first in their thinking, setting aside the truth, which means that the models that they wind up believing are not truth. So this is not a battle of religion versus science. We aren't believing in the Bible due to blind faith. Science is on our side because our cosmos indeed is finely tuned, and that's because our cosmos is designed. Because as Psalm 19 says, the heavens declare the glory of God and the firmament shows his handiwork. Something that interests me is that the Lord could have created the cosmos any way he wanted, to look any way he wanted. He could have made it look, I'm going to back up a minute. He could have created it in such a way that it could be potentially explainable by long natural processes over long periods of time. Now, he could have done that and still told us to accept that he created it, as the Bible says, and he would have been certainly within his rights to do so. But in his grace, he didn't do that. He placed us in a universe that looks designed. And I'll be talking more about this tomorrow morning. Because indeed, the heavens do declare his glory in many ways that we are only now just beginning to understand.